And I'm going to discuss very quickly the physical chemistry test papers. If you have any doubt, please enable chat box so that I can see if there is any doubt. Students can ask that doubt on the chat box, or you can else straight away uncam yourself and ask me straight away. The question was very easy. This question paper was quite easy. The physical chemistry part especially was quite easy. So question number 19, if I talk about, this is about, yeah, Doma, you want to say something? Doma Gautam Reddy. Somebody accidentally uncamped. Because in my chat box, I could not see anything. Yeah, Priyanshu Naik, you have any doubts? Okay, so in case you don't have any doubt, I'll generally discuss all the questions. Okay, then I will just express my opinion.
Sir, leave a single correct, sir. All are quite easy.
Yeah. They're quite easy. You're absolutely right. Still, I just have to do that. Otherwise, the discussion
Yes, sir.
part is there. Other teachers will join later on. Organic chemistry part, Ashish sir will join. Organic chemistry part later on. Just keep it accumulating. Rahul sir will discuss at some time. He is not available today. So all the papers are with us. In physical chemistry part, most of the questions were easy. Like only I will go to discuss question number 19, for example. It is related to Friendlich adsorption isotherm. And the funda of this question is that adsorption is inversely proportional to temperature, because the entropy of adsorption, delta S adsorption, is negative. And you can see that that means that delta G naught for the adsorption, which is delta H naught minus T delta S naught, let's call the standard value. So if the delta G naught is related to minus RT ln K equilibrium, you can also relate this like this. So in the case if delta S is negative, so if you increase the temperature, then what happened? The delta G naught value is going to increase, and more the delta G naught is going to increase, the K equilibrium for this process is going to decrease. And what is the K equilibrium for this process? So in this process, basically what is happening, the gas is getting into what? Solid form. Say solid form, because it is getting sticked on a solid surface. So you can say the equilibrium constant of this is getting smaller. In this way, you can think about it, that adsorption is decreasing. But when it comes to this is physical adsorption. When it comes to chemical adsorption, the only thing is, just keep it in mind, just recall to all of you that for chemical adsorption, the graph will, if you take X by M and at constant pressure, and you just take a temperature curve, it first increases, reaches a maximum value, and then it decreases. You might be aware of this fact. So it happens to be physical adsorption, nothing like T1, T2, T3. Lesser the T1, greater is the extent of adsorption, lesser the temperature. So you can see the extent of adsorption is maximum in this case where the temperature is T1. So of course, temperature here is the lowest. Answer is C. Next question was a simple model for electrolyte concentration cell involving a metal M. That's a very simple question. And I don't think there is any doubt in this. And still, if you wish, anyone would like to ask this doubt, that I would say that this in these cells, E naught cell is equals to 0. How to quickly solve it? So I don't know. Maybe you can think about it that this is a cathode, and you can see that in cathode, the concentration of metal ion is less. So let me just give you a slight part of the theory. If M plus is less, there is a great tendency of this metal to oxidize. Why? Let me relate it to G. Lesser the value of M plus, okay, is M plus concentration decreases, G of this M plus is given by G is equals to G naught plus RT ln concentration of M plus. So you can see if the concentration of M plus is decreasing, then G is decreasing, and which relates that if this M plus is less, if this is less, then there is a more tendency to get oxidized. So what is happening, you can see here, this is 0.1 and this is 0.05. So quickly you can come very easily, you can relate that this is here, the process of reduction is less. I mean, it has a lesser tendency to get reduced as compared to here. So in this case, you can simply know that E cell is going to be negative. If E cell is negative, and one thing is sure that there should be zero, you have three options B, C, and D, where there is 0, 0, and 0. There are one positive value, you can discard this. So the competition between C and D, and then you have to solve it to get the answer. I think it is also very easy. This is not worth discussing this physical chemistry paper. I don't know why such easy paper has been given. Next question was also very easy. Question number 23, because you can see in all these cases, the hydrogen ion is H plus ion is involved, but only in this case, H plus ion is not involved. Let me moderate this question and ask you, can you tell me in which case, if you increase the H plus ion concentration, then E will increase most sharply? If somebody asks you, what is the impact of H plus ion concentration on A, B, and D? In which case, by changing H plus ion concentration, the EMF is changing fastest. If I ask you, anyone can answer this question? What will be approach to solve this question? If suppose I give a twist to this problem, and if I ask you that all right, MnO4 negative, Mn2 plus, Cr272 negative, Cr2 plus, 2IO3 negative, in these cases, in which case the EMF will sharply change, most sharply change with pH. So what will be your approach to answer this question? Let me answer this question. It will be answered like this. Anyone?
B option.
A option?
B
Let
option.
B option. Let me check. What is the approach of answering this? Please give me the answer.
More number of H plus are required for that reaction in option.
No, wait, Prakash. Just wait. I'll tell you. This is 4H2O, this is 8H plus, and this is 5 electrons. See, most important thing is electrons here. If you write the half cell reaction, it will be E is equals to E naught minus RT upon NF. See, everything is common. This N is different here, okay? So let me see this. Tell me, ln of Mn2 plus you will write here, and here MnO4 negative you will write here, and here H plus you will write here raised to the power 8. So basically what factor you're looking for is, you see, minus 0.0591 divided by N. What is N here? 5. And if you take here, just do it plus log, you probably understand, sorry, log, log H plus raised to the power 8. Take this 8 here. So basically there is a factor of 8 by 5. So your answer should be, the slope will be maximum in this case. This 8 by 5 is maximum. You understand what I'm saying?
Yes, sir.
Yeah. So this factor is the most important thing. If somebody gives you this question, just changes like this. So if you compare this with Cr272 negative, then it will become very interesting. Okay. So give a slight twist to these problems and they will become very interesting. Isn't it? Here you will write 14H plus, then you will write here 6 electron. This time the factor is going to be, you clearly understand the factor is going to be what? 14 by 6, which is 7 by 3. So you have to compare in which case the EMF is going to change faster. And you know that, of course, H plus ion concentration, if you are increasing by Le-Chatelier principle, more and more H plus ion you are adding, more tendency to go in the forward direction. That means reduction potential is going to increase with increasing H plus ion. Then the slope is given by 7 by 3 here. Slope is given by 5 by 8 by 5 here. Now, which one is bigger? I don't know. This question could have been very twisted. So in advance, you should expect question like this, not very straightforward question. Thank you for response. If you keep on responding, then now the question number 25, what about this? In question number 25, I would say the only part I would do it faster to make this question, tackle it very faster. I will never take this hydrolysis as a hydrolysis. I will take this like this base is weak base Kb is equals to given. Kb is 4 into 10 to the power minus 5. and the weak base is there, something like ammonia. So if ammonia is there, it will become what? NH4 positive, salt of weak base. So this NH4 positive is basically an acid. So if it is an acid, it is going to give H plus ion. So K of this acid is equals to
PDF పెట్టుకున్నారా
Kw upon 4 into minus 5, which is equals to 10 to the power minus 9 into 1 by 4. This is the K. And I will just make my calculation faster. This K is equals to this, and I don't really need to ignore, assume H is very, very much less than this, because it has been given that pH of the resulting solution was found to be this. So if pH is 5, that means H plus ion concentration is 5, 10 to the power minus 5. And then the counter ion will also be 10 to the power minus 5 divided by whatever concentration C is there. This must be equal to 10 to the power minus 9 into 1 by 4. That will make your calculation faster. So you quickly calculate C. C is coming out to be 4 into 10 to the power minus 10 and divided by 10 to the power minus 9, which gives you clear value of 0.4. Okay, so this calculation is just faster. See, I have not used any hydrolysis formula. And in this problem, basically you need what? The concentration. Because from the concentration, you have to 80 grams of the salt is there. If you get to quickly come to know about the concentration, 2-liter solution is there, then you will calculate the molar mass of the salt. And molar mass was required. Rest all is easy. Any doubts here? Am I clear what I've done?
So one's gonna solve option C.
Option C, density of the salt test. How to solve this? Okay. So it is already NaCl type of, XY forms a BCC type of crystal. So there, when we say BCC, that means body centered cubic. I think there is a mistake here. It is not BCC. The quality of the question is, you would say that you can avoid this. There could not be BCC. Body centered cubic. It should not be called body centered cubic. It should be called what? There is a cation here, and these are the anions. Should we call it body centered cubic? Strictly no. This is basically what? It is simple cubic lattice. Simple cubic lattice. So sometimes if a student is very well read, they might be get confused. Might have noticed. We should not call it BCC. What is this? It is a simple cubic lattice in which the body centered void. What is this void? Body centered void has been taken by someone else. So in this case, the Z is equals to what? 1. Number of formula units per unit 1. So density D will be equal to Z into M upon Na. And regarding this A cube, you have to just think about it that they are touching where? Along the body diagonal. So root 3A by 2 is equals to R plus R minus. So basically you have to use this formula to get the value of density. Now molecular mass you will get from the solution calculation. Na you already know, and I hope that that is given. Rx and Ry is given. Clear? Hai? So you can calculate density then. Done? Should I move ahead?
Sir, actually, I'm getting option C as correct, sir, but in key he has given that it's wrong.
You have done everything all right? See,
yes, sir, same thing.
Same, then you have to check the options here. Z is equals to 1. Okay. And I can tell you that I have also saw some mistakes here. So you should report it to the authorities. They will get the change. Otherwise, I'll check it out. Okay. After this class, I'll see the calculation. I'll tell you. And I'll tell the Prasad ji to make changes. Okay. Next question is the heat of neutralization of strong acid and strong base. I think this is also very easy question. Okay. Done. So that part is quite easy. Very easy question paper, I would say. In the closed vessel, initially pure NH3 is present at T Kelvin. At a given temperature, ammonia recomposes to produce this and this. According to first order kinetics, reaction is 50% completed in 13.8 minutes. This is also very easy question. Any comments on this one? 50% completed in 13.8. So you come to know that ln2 by this T half 13.8. Immediately you get the value of K. And also after infinity time, there is the reaction is nearly 100% completed. Total pressure of the vessel is found to be 1 atm. That clearly gives you idea that you started with what, because NH3 was changing into N2, half N2 plus 3 by 2 H2. You can clearly see 1 mole of this is changing into 2. So you might have taken 1 atm pressure. The examiner is quite, examiner is quite lenient. He has given you this value. So initial concentration, you come to know about it, 1. You just have to find out how many minutes before the bearing total pressure in the vessel is equal to 1.8. When the total pressure is 1.8, then you can say that 1 minus x, and then of course here 2x, that should be added to become 1.8. Clearly 1 plus x is equals to 0.8. So you got a very neat and clean factor of k is equals to kt is equals to ln of 1 upon 0.8. Since x is equals to, 1 upon 0.2. 1 upon 0.2, that means ln of 5, and ln of straight away ln of 5 value is also given. So I think that you have to choose this ln 5 value and get the answer. So I don't think any special difficulty level in question number 32. And I'm very sure that ITJ is not going to ask such silly questions. And if they're going to ask some such simple questions, then you should have only this thing, don't do mistakes. Okay, question number 35. Also, this has been asked in ITJ way back 10-20 years back. Still, it is getting repeated in this case also. Question number 35. I think that that is also a straightforward question. Not much discussion is required here. Heat of neutralization of strong acid. Yes.
Option A and B should have kilojoule per mole
Yeah.
by definition.
By definition, it should be kilojoule per equivalent. You are absolutely right. And not per mole, per equivalent. We used to call it per equivalent. So I think that this is such an obvious thing. That is why you have taken along. Small mistakes are there, but you should sense by the paper, by the tone of paper with Prakash, you should sense that examiner is not going to be so, he is slightly casual. Sometimes in ITJ also they're very casual. They've done plenty of mistakes. So in ITJ examination, you have to score marks. You don't have to show that what kind of a national level examination this is, what kind of silly mistakes they're doing. Okay. In chemistry, you'll often find some kind of slippage. So don't try to, be adamant over there. What else could be there? I think examiner is not going to judge only by this thing. Now, you understand what I'm saying?
Yes, sir.
Yeah. So even if you're losing marks here, it's all right. But in the IT examination, you should contest. You should say that my instinct were telling that it could be only 51.46 kilojoule per equivalent. Otherwise, your valid challenge is very valid. Question number 21, you find any difficulty? I have not solved it. Anyone finding any difficulty? I'll just tell you the funda of this problem. If you have any difficulty. Frankly, I have not solved it, but I can tell you the argon gas is just there to confuse you. It has nothing to do with anything. And very important thing is this vessel is of constant volume type. So argon gas is not going to affect it. Okay. The question will be very interesting if this is a constant pressure vessel. Then it could be very, very interesting. But I think that it is given the D option on removing argon from the equilibrium mixture at constant pressure and temperature, the extent of dissociation of PCl5 will increase. Anyone want discussion? I will discuss the theory of this and some interesting problems could be made. No discussion, okay? Okay.
Sir, option D in that.
Option D in that, okay. So in option D in that, on removing argon from equilibrium mixture at constant pressure. So you immediately visualize this like if it is at constant pressure, if the gas is at constant pressure, you see what is happening. This is pressure P is equals to constant. So PCl5 is there, PCl3 is there, Cl2 is there, and argon gas is there. And you're removing it at keeping the pressure constant. So what will happen? Definitely piston will come down. And when the piston will come down, that what will happen? All the pressures means what? PCl5 pressure of PCl5, pressure of PCl3, pressure of Cl2, all will jump by a same factor. What is the factor? Suppose everyone is increased by a factor of x. If everyone is increased by factor of x and your equilibrium was represented like this, PCl3 and Cl2, your equilibrium constant K is equals to pressure of PCl3, pressure of Cl2 divided by pressure of PCl5. So this is jumped by a factor of x. This is jumped by a factor of x and x. So obviously what happened? That this ratio become what? Greater than k. This ratio become what? Greater than k. If that is the case, then q become greater than k. Then what happened? Equilibrium will shift in the backward direction. One way of doing it like this. Okay. The other way is, if you remove argon at constant pressure, volume will increase. The net result is increase in total pressure. So increase in total pressure will take the equilibrium backward direction. Clear? Hai?
Sir, while removing argon, we are actually decreasing the pressure inside. For pressure to be maintained constant, molecules have to dissociate more, sir.
Why don't you think like this? That if you are removing argon, keeping the pressure constant. Okay, that is why I have shown you the container. If you remove argon and you have to keep the pressure constant, then what will happen? Piston will definitely come down. Do you agree? Do you agree? Please give me answer. Suppose take the 2 atm pressure is there, 2 atm pressure is there, 2 atm pressure is there. Argon is 2 atm. Now total pressure is what? Total pressure is maintained at what? 8 atm. Got it? Now what is happening? If you're removing argon and keeping the pressure constant, how can you keep the pressure constant removing argon? Only by taking this piston down.
Sir, but
In question, he gave volume is constant, sir.
Yeah, in fact, that is why I told you, then it is impossible situation. Because if you're keeping volume constant and removing argon, let me think about your point of view as well. Okay, all right. In an evacuated vessel of capacity this, 4 moles of argon gas, 5 moles of PCl5 was introduced, temperature is maintained, and equilibrium total pressure of the mixture was found to be 4.8 atm. Now correct statements are there. Degree of dissociation is okay, all right. Kp for this reaction, okay, all right. At equilibrium, total moles of gases are, you will calculate it eventually. On removing argon gas from the equilibrium mixture at constant pressure, how can you do it? Yeah, then you are right. You're right, Yesh. If you are on removing argon from the equilibrium mixture at constant pressure, so then the extent of dissociation PC will increase. No, by your point of view, nothing will happen. But then it is inconsistent because you could not maintain the pressure constant, na?
Sir, they didn't mention volume is constant.
Yeah, they have written here in an evacuated vessel of capacity 49.2 liter. That is a contradictory thing. He's right in one respect. See, that's what I'm telling you. If you are not making a problem carefully, that's a very easy situation. But a similar slip of, thing and this problem become complicated because there are two contradictory things. You have taken evacuated vessel. So vessel means what? Vessel. There is no piston fitted with this. It's a constant pressure vessel. You're right. That way I can understand your confusion, okay? But once again, I am just giving you by common sense that don't be so fussy about it. Otherwise, really this D option is controversial. On removing argon from the equilibrium mixture at constant pressure. This is very, if you have to maintain pressure constant and you still have to remove it, so what is going to happen? How it is possible? You're adding now, if you're adding something, what you are adding? Either you are adding PCl5 or you are adding PCl3 or you are adding PCl2. Okay. Probably you are doing something like this. You're adding in such a manner that equilibrium ratio is maintained. That is also you can do. If that is the situation, then this D option is a very difficult option. Understood what I'm saying? Let me check what the solution is given. So what is given in the solution?
Option D is not
Yes, sir.
mentioned.
Option D is not correct, na?
Discussed. I mean, they're given not correct.
Okay. So there is a little bit of controversy. You can contest it or removing argon from equilibrium mixture at constant pressure and temperature. The extent of dissociation of PCl5 will increase. So you want to say that we have done something like this, that what was the pressure? Equilibrium pressure was 4.8 atm. 4.8 atm was equilibrium pressure. And this equilibrium pressure was total. You have removed, there is some part of it from argon. Pressure of argon was also there. So you have been situation is like this, that Kp is equals to pressure of PCl3 into pressure of Cl2 upon pressure of PCl5, and their product was equal to Kp, and their sum PPCl3 plus PCl2 plus PCl5, their sum was say somewhat less than 4 atm. Sum was there. Now what you have done, you have added something like x into this, y into this, z into this to make this 4.8 atm. You made it 4.8 atm. You thinking like this. So their pressure becomes what? The initial equilibrium pressure plus x and all this, these quantities become, and you have added in such a manner that equilibrium is not disturbed, or the equilibrium is once again attained. And here you are going to check that under these situations, what is alpha. So I think that your imagination is going wild, and this question will become then additional question, a very big question. Okay, what do you think? Examiner is going to ask this question, the D option? I don't think so. So I think that I hope that you are getting what I'm saying. Don't think such a wild thing. Otherwise, this is a valid thing. If your imagination is telling you this, you might think like this. I hope I'm not confusing you. There is, if you start thinking like this, that simply means this, which don't seems plausible. It's a very famous question. What happens when you remove or add inert gas at constant pressure? The question is related to that. So I close this discussion because you don't require to go to such depth here. Otherwise, this problem then will be take half an hour of yours, how you study other questions. I think 28 number question is quite easy. I don't think there is any discussion is required. But organic chemistry, this is, you should be taking this to the Ashish sir, because I'm not authority here, but it is a 1,4 addition. You have to add HCl, then see the carbocation stability. There are two products. What is the problem here?
Sir, as I thought C and D would be correct, but he gave only A and B.
Okay. So when you add HCl, then kinetic and thermodynamic control, if you talk about, so the H plus ion is added, and this H plus ion could go at this point. Suppose you've added here H plus, one H plus is added, suppose at this point. So this is the case, and then this is going to be like this positive charge. And if you add the positive charge over here, then you get a positive charge over here. And these are the two products. So addition of HCl, I think at this point is leading to this carbocation. And on this carbocation, if you're adding Cl, that is fantastic. So I think this 2 should be a thermodynamic product. It is a more stable product, it seems. The other one is going to give you, the transition state is more favorable here. So it is a kinetic product. 2 seems to be a kinetic product because transition state is more stable here, and the first is thermodynamic product. So one is kinetically controlled product KCP, they're telling. 2 is thermodynamically controlled product TCP. I don't think so. I think this we have done it. You understand what I'm saying? Although I am not supposed to be discussing this is the purview
Yes,
of
yes.
Ashish sir. But by common sense, I can give you the answer that if you have this compound, and if you're adding H plus ion concentration on this one, then what is going to happen? There are two options. Either H plus ion is coming here or H plus ion is coming here. If H plus ion is coming here, you're going to get this product. This is the intermediate. And if H plus ion is you are adding here, then you are going to get this intermediate. Now, of course, this intermediate is also stabilized, okay, and also stabilized like this. Carbocation is going at these two centers, all right. But as you can see, this transition state, this is more stable if you are getting this, because not only it is stabilized by this is also tertiary. So this is more stable. So kinetic product should be approaching this behavior, and thermodynamic product should be approaching the second behavior. That's my opinion. I've not seen the solution. Okay. So you please ask Ashish, sir. You asked me because there is a tradition that we don't discuss all these subjects. Okay. Those who are only experts, only they discuss. Common sense answer I can give you. Okay. Done.
Yes,
Yes.
fine.
Yeah. Thank you very much. And I think time is over. Otherwise, I would have discussed some other questions as well. Next class discussion, I'll take up previous paper, some interesting thing. I could not get time. So I will utilize half an hour of my time to tell you some interesting things about the variations in the problem which could be asked in the paper. Thank you, bachcho.